Hi everyone! Today we're going to start a new exercise that will give us a chance to work with I/O in a realistic environment. So no more reading and writing to the console. This exercise could be a real task we do in our job. So imagine we work for a company called Lambda Corp, which aggregates flight data so that customers can find the best way to reach their destination. The main interface of our website is a form which captures 1. The airport of departure, 2. The airport of arrival, and 3. The date of departure. In practice, a website like this also captures additional inputs such as the number of travelers or an optional return date. But for the purpose of this exercise, we'll only focus on these 3 inputs. Then, when the user presses the search button, they are redirected to a new page which displays their search results. In particular, they will see a list of flights with lots of metadata for each flight, such as the name of the airline, the departure and arrival time and location, the duration of the journey, the number of stops, and the price. Additionally, the website also provides convenient shortcuts to the cheapest, fastest, and best flight, for some definition of best. Now let's have a look at what happens behind the scene when the user presses the search button. The user sends a request to the Lambda Corp servers with 3 properties: the from and to airports and the date of travel. Then Lambda Corp forwards this request to several data providers, such as British Airways, lastminute.com, or Swissair. Each data provider returns with a list of flights, and then Lambda Corp aggregates all the results and computes some of the shortcuts we saw earlier, such as the cheapest, fastest, and best flights. These shortcuts could have been computed on the front end, but our technical team decided to implement this feature on the back end so that the payload can be consumed immediately without further processing. This is probably a good idea since the list of flights might be very long, which may require pagination. Okay, now that we have a general overview of the workflow, let's open the file search flight service in the package exercises.action.fp.search. As usual, be careful because there are other files with the same name in other packages. Search flight service represents the main API of Lambda Corp servers. It has a single method, search, which takes the 3 inputs we saw previously: the airport of departure, the airport of arrival, and the date of departure. Then search returns an I/O of search result. It's an I/O because we're going to contact external systems. So let's open search result. This is a case class which contains a list of flights and compute the cheapest, fastest, and best flight from this list. As you can see, the implementation of cheapest and fastest is relatively straightforward. It calls the method min_by_option and specifies which field we want to use for sorting. However, best uses a slightly more complex sorting strategy, which is defined as a companion object, with best ordering. The best ordering orders a flight by the number of stops, and if there are multiple flights with the same number of stops, it orders them by price, like here. This means that the best flight is the cheapest flight with the least amount of stops. Now let's open the class flight. It's also a case class which contains a flight ID, which we assume to be unique, the airline name, the airport of departure and arrival, the time of departure, the duration of the flight, the number of stops, the unit price, and finally a redirect link that the customer will use to book the flight. Okay, so now let's go back to the file search flight service. So the first exercise for today is to implement the method from_to_client, which is defined as a companion object. This method creates a search flight service using 2 search flight clients. If we go back to the diagram, we can see that the service is the API that Lambda Corp maintains, while the client represents the API of a third-party data provider. For the purpose of this exercise, we assume that all data providers use the same API. For example, let's say it's an open standard. To put it another way, From to client is a simplified version of the problem where we only fetch and aggregate data from 2 data providers. And hopefully once we solve this problem, it should be easier to generalize to many clients. Cool, so now it's your turn to implement from to client. One thing to keep in mind is that when we aggregate all the flights from client 1 and client 2, we want to order them using the best ordering strategies that we saw in the class search result over there. So we want to use this ordering. You can also find an example-based test in the class search flight service test. Don't forget to enable it. Okay, so let's give it a try. First thing we want to do is to call basically search on client 1 and client 2. We want to dispatch the search to each client. So we'll call the method search and we'll pass exactly the same parameters, from, to, and the date. And we'll do the same for client 2. So search on a client returns an IO of list of flights. So we need to combine these 2 IOs together. The way we saw how to do this in previous lectures is to use a for comprehension. It's probably the simplest way to do it. So we'll just copy-paste these 2 lines, add a yield keyword at the end of the for loop, which will make it a for comprehension. And then we need to assign a name to each result. So we say flights 1 is the name of the variable that we get from client 1, and flights 2, the name of the flights we get from client 2. So flights 1 and flight 2 are both list of flights. Then we want to concatenate them together and package them in a search result. So we can say search result. This is a case class that takes a list of flights as input. So we can say flights 1 plus plus flights 2. Yep. Cool, so let's run the test. We'll enable it first and run it. So let's have a look at what the test is failing, but let's have a look at what it was supposed to do. So this test is creating 4 flights, 1, 2, 3, 4, with different stops and prices. Then we have client 1 will return flight 3 and flight 1. Client 2 will return flight 2 and flight 4. And we expect that when we create a search flight service using these 2 clients, we expect to get a list flight 1, flight 2, flight 3, flight 4. So this is the expected order. But at the moment, if we look at the error message, it says that it expected to see flight 1 at the top of the list, but we see flight 3, which kind of makes sense because we haven't done any sorting yet. At the moment, you see flight 3 is the first flight we get from client 1, and because we use plus plus to concatenate, to combine the flights together, at the moment the flights from client 2 are always at the end. So even though the second data provider might return very good results, we always put it at the end of the list, which is very unfair. So what we need to do is to add some kind of sorting here. So what we can do, there is a method sorted on a collection. And sorted takes an ordering. So this ordering is how to order basically flights. And we saw that in search results, we have an ordering of flights, so it's all ready. We just need to say search result.best ordering, and it will sort the flights according to this ordering strategy. Let's rerun the test. It passes now. Cool. Let's clean it up a little bit. It's maybe a bit doing too much inside the yield. We could create a variable here that says we combine the flight and sort it, and here we pass it here. It's the same thing, it's just creating a variable to make it slightly more readable. Cool. Before we move on, I would like to show you something about search result. So search result, this case class, as you can see at the top of the file, has a comment that says flight, so this variable, is expected to be ordered using the best ordering strategy. So probably the author of the file thought that we need to respect this invariant, so we need to always order this list. And as the author of the file, it's quite easy to remember such a thing. I mean, maybe in 6 months you will not, but at the moment it's quite simple to remember. But your colleagues will probably not know about this comment. So I think the problem with comment is that it's very difficult to enforce, it's very easy to forget. So what we could do, what would be nice, is if we could force the creation of a search result so that the flights are always ordered, so that we don't have to remember, it's done automatically. So one way to do this is to define a custom constructor for search results. So because search result is a case class, it has an apply method defined automatically by the compiler, but nothing blocks us from defining our own apply method. And when we do this, we basically erase the default one. So we provide a new default apply method. And here we can sort the list of flights. So we can say flight sorted using best ordering. And then we create our search result with this list. Oh, actually, as you can see, this method is actually recursive at the moment, because when you do search result sorted, we call the apply method. So we're actually calling ourselves, which will create an infinite loop. So what we want here is to call the constructor of the class, the default constructor of the class, we can do this using new. We can say new search result, it will call the constructor over there and not the apply method. So now the nice thing about this is that if we come back to search flight service, we don't have to remember about sorting. We can just say flight 1 plus flight 2, and the sorting should happen automatically. Let's run the test. Yeah, all good. Now, it's very nice like this, but potentially someone could, there is nothing blocking you from using new search result here. And in this case, if you do that, it will actually break the test, because if you do new search result here, you call the default constructor of the class, which doesn't go through this sorting method. So it's very unlikely you're going to do this in practice. It's very rare for people to use new, but it is still possible. So one thing we could do to avoid this situation is to make this constructor of the class private. So one way to do this is to add a private keyword here. So it's a bit of a weird location. You might have expected to add a private keyword over there, but if you do this, you make the class private. While here, what we want to make is just the constructor private. So that's why you need to add private between the class name and the arguments. Now that this constructor is private, we can still call it inside the companion object, because the companion object has a special relationship with the class. It has access to private methods. And now if we come back to search flight service, we can see that the constructor of the class is no longer accessible. We cannot do new search result within search flight service because the constructor is private. You can see no constructor accessible from here. So now we are actually really forced to use the apply method, which guarantees that the input is sorted. Next, we are going to tackle a corner case of from-to clients. It's possible that several clients return data for the same flights. For example, if we connect to both British Airways and lastminute.com, it's possible that lastminute.com returns flights chartered by British Airways, in which case we want to remove duplicates. This means that if we get several flights with the same flight ID, we will only keep the cheapest option. Now I'll let you pause the video and update from-to clients so that it handles duplicate flights properly. Okay, so where should we implement this logic? We could do it within from-to clients. We could say, when we get the list of flights, we could remove the duplicate at that point. But I think a better place will be inside of the constructor of search results, because here we get the aggregated list of flights, and we could remove the duplicates here. It will be much simpler to test, because here we don't have to deal with IOs, we don't have to deal with clients and mocking them. It's much simpler to deal with and to test. So assuming we do it here, let's write a test for this. So what we could do is basically copy-paste our test for search flight service and move it inside of the test suite for search results. So there is this search result test here that at the moment verifies stuff around the cheapest, fastest, and best. You can have a look at this test suite later on. So the idea here is basically to add an example base test for the apply method. So here we'll first check the sorting, and then we'll check the deduplication. So this means that we can remove all the thing about clients and IO, and the only thing we really need to do here is to create a search result based on this list of flights. So we can say, let's put it in the wrong order. So let's say flight 2, flight 4, flight 3, and flight 1. So imagine this was the input we get in the apply method. We do expect to get this list at the end. So we expect search result to sort everything. So maybe we could say apply sort. So let's run this particular test. Cool, so it passes. So now we know that we haven't changed anything. We just moved the test from search flight service test to search result test. Now let's add the deduplication. So what we could do is to create two flights with the same ID. So we have flight 1A that has ID 1 and flight 1B that has ID 1 as well. And let's make one slightly more expensive than the other. And here we'll say, let's say flight 1B is first, and then we have flight 1A next. So in this case, we have two flights with the same ID. We do expect to get only one at the end, and we want to get the one with the cheapest price. So let's do it like this, and let's run the test. So now we expect the test fail because we haven't implemented the deduplication. Indeed, it fails. So it says that first item in the list is flight 1. So it is the correct flight 1, the 189.5. So now, I mean, we know that the sorting is correct. The only thing is that we are not yet deduplicating because the second item we return is again flight 1 while we expected flight 2. So let's implement this deduplication logic. We can do it here. So let's call this variable distinct. So this will be the list of flights we expect to get without duplicates. So there is a method on collection called distinct by. And distinct by, you can specify what field you want to use for uniqueness. So we could say flight ID. And then we are guaranteed that the resulting list will have only one item per flight ID. So this will remove the duplicates. However, the problem with distinct by is that we don't know which flight will be selected. It could be the most expensive one, which we don't want. So actually what we need to use is a slightly more complex method called group by. So group by will say again group by flight ID, but this is going to return a map where the key, so you see the key is a string, so it's the flight ID, and the values are all the flights with the same flight ID. So let's do this. So this will be flight ID, and this is flight same ID. So now that we have a list of flights with the same ID, what do we want to do? We want to select the cheapest option among this. So we'll just say flight same ID, and we'll use the method min by, and we'll say min by the unit price, because we want to select the cheapest option among this. So maybe let's reformat it slightly. Yep. So we don't need the flight ID, we can remove it. Min by potentially is a dangerous method because it can throw an exception if the list is empty. But because group by is only going to return lists that are non-empty, we can use min by here. It's completely safe. So now let's pipe. So the first step is to remove the duplicate. The second step is to sort everything. So we'll say distinct.sorted. Well, actually, it doesn't work now because distinct is an iterable of flights. This is because we use, like, in this step, we got a map, and then we map it to get a single item out. So, the collection library actually returns an iterable, so we can convert it into a list to just make it work. It may not be the most efficient implementation, but for now, we more care about making it right. We can always optimize later on. Cool. So let's run the test to see if it passes. Yes, it does. Awesome. The nice thing about this approach is that now all the aggregation logic is inside the apply method. So as we've seen, it's easier to test. We could, as a bonus exercise, you could try to write some property-based test around apply method, because at the moment we are just have a hard-coded test. But potentially we could write some useful property-based test. And you can always check my answers to see the one I came up with. But the nice thing about it is that all the logic is encapsulated in the constructor, and it means that inside of the service we don't really have to worry about this. Now, when we aggregate two clients, we just say plus plus, and all the sorting, filtering, and everything is handled by search result, which is very nice. And potentially later on, when we'll want to aggregate more clients, result from more clients, it will be very useful. Okay, now the last question for today. Imagine one of the clients throws an exception. How does the service handle this situation at the moment? Please pause the video and think about it for a minute or two. Currently, the service propagates the errors to the customers. This is because we use a for comprehension to compose IOs together. And in previous lectures, we saw that for comprehensions concentrate on the happy path. This means that if any IO inside the for comprehension fails, the overall result is a failure. Now for search flight service, it's probably not the desired behavior, because eventually we'll aggregate the results from dozens of clients, which means it's quite likely that at least one of them will fail from time to time. And we don't want to offer a poor user experience. So let's update from to client so that if any client fails, the service will simply ignore the error. In other words, we consider a client failure to be equivalent to a client returning an empty list of flights. Please pause the video and update from to clients. Okay, so the first thing I would like to do is to write a test for this scenario. So what we could do is copy-paste this example and say from to client should handle errors gracefully, something like this. And so we don't really care so much about the flights. We just say, okay, flight 1. Then we have one client that return a list of flights, which was one item inside it. And the other one is going to blow up. So it's going to return an exception. So we can say IO fail, new exception, boom. Yep. So when we combine these two clients together and we call search, we expect to get a list with flight 1. Or in fact, what we could do is just check that when you call search, we expect that there will be no exception in this case. So we could say something like, we could use the method attempt. Here, attempt is going to transform the search normally return an IO of search result. Now it's going to return an IO of try of search result. And then here we can say, we expect the result to be a success. So in other words, we expect that even though one of the clients blew up, we do expect that we get a success at the end. Cool, so let's run the tests here. So at the moment this test should fail, yes it does. At the moment it is a failure. We do throw an exception. So let's come back to the implementation. So what we want to do here is to do something in case an error occurs. So the IO API has a couple of methods for error handling. We have attempt that we saw that it allows us to detect if it was a failure or a success. So we could say if it is a failure, do something. We have on error that gives us a cleanup function that in case an error occurs, we can do something, but anyway it's going to rethrow the error, so it's probably not what we want. And we also have handle error with, which is more like a kind of a flat map, but for failures. So handle error with give us access to the failure in case it occurs, and lets us do something with it. But in case it's a success, it keeps the result unchanged. So I think this is probably what we want to do here. So we want to say in case there is an error, what do we want to do? Well, we want to simulate the client returning an empty list of flights. So it's actually just an IO of nil. So it's basically an empty list, but we just wrap it in an IO because that's what the method needs. And we don't really care about the error. So we can do that for both clients and rerun the test. Yep, it works. Nice. One thing we could do here is that it's a bit annoying to duplicate this handle error ways in both cases. We might do more transformation later on, which will make it even worse. So what we could do is to create an anonymous function within search. So we could say search by client. So this method is just going to define how do we search for one particular client. So let's copy paste this line here, and we'll just say client. And here we can say search by client with client 1. And this will be search by client with client 2. So this will remove a bit the duplication. And let's add type annotation. Let's rerun the test. All good. Nice. If we want, we could add, because at the moment it's not extremely realistic that we get an error but we just ignore it completely. Probably in reality you may want to log the error. So we could do it here just to make it a bit more real. I created a method debug in the companion object of IO. So this is not a real method that we should use in practice. It's just going to do a println. In practice, we'll probably have a proper logging library. But it's just like just to play with it right now. So we could say, okay, let's pass an error message. We'll say, oops, an error occurred. And then maybe we can log the error, something like this. Occur, and I can never type it. I think it's like this. Yeah. So this io.debug is going to return an io of unit. It's the equivalent of a println. And then we say once we do this debug message, we return an empty list. So we'll still ignore the error, but we'll just at least write an error message in the console. And let's rerun the test to verify that it all works. Yeah, nice. So before we wrap things up for today, I would like to review the way we tested this scenario. So far we verify that if the second client fails, then we ignore it. However, we don't check what happens if the first client or both clients fails. We could add the test examples for these cases, but the code will be very repetitive. Instead, could you write a property-based test that checks that the service always returns a success, even if some of the clients fail? It's a difficult exercise, but I encourage you to give it a try. And you can find some custom random generators for this particular exercise in the same package. So you see there is this class search flight generator, where I define a generator for airport, a generator for flights, and so on. So you might find this generator very useful for this property-based test. So please pause the video and give it a try. Okay, so one way to generalize an example-based test into a property-based test is to look at everything that is hard-coded and randomize it. So for example, the search at the moment specifies Paris Orly and London Gatwick for the airports, but we could randomize it. So we could say, okay, for all, so this is going to take a couple of generators. So let's just create the skeleton and move all the code inside of for all. So say, for example, first let's generate the from and to airport. So in order to do this, we'll say airport gen. So we'll use the generator for airports to generate the from and to airports. And then we can say from and to. The test should still pass because it doesn't really matter that it is Paris or London. Yeah? Still good. Same for the date. So we could say we can use the date generator, date gen, and then inject it here, which means that we can remove this variable here. Let's rerun the tests. All good. Then next, we don't really care about this flight. We could generate a random flight. It doesn't really matter. So we could say flight and use the flight generator to generate it. So let's do this. And let's do that. Let's rerun the test once more. Still works. And in fact, we also don't care if it returns a list with a single flight or many or just an empty list. We just want a random list of flights. So we can use, there is a method on gen called listof. So listof takes an existing generator and generate a list of values for this generator. So this will be flights. So flights now is a list. And we can straight away inject it here. Nice. Let's rerun the test. All good. And next, same for the exception. We don't really care that it is this boom exception. We just want an exception. So we can say, let's generate an error. Here for this, we probably want to summon the default generator for exception. And one way to summon the default generator is to use the method arbitrary. So arbitrary, you specify the type you want to get. So I can say throwable, for example. And this will generate a default throwable for me. If there were no such default generator defined for throwable, then the code will fail to compile. Cool. Let's rerun the test, all good. So if you want, so far, we haven't really done anything except just randomizing the input, but this test still does the same thing. Now, the annoying part is that we still test, like for client 1 return a success, client 2 return a failure. Ideally, we would like to swap, and we would like that both of them return a success, both of them return a failure, all combinations. So if we want, we could add like Boolean, random Boolean, and say, okay, if the Boolean is true, let's return a success. If the Boolean is false, return a failure. But it's really painful. A better way to do this is to define a random generator for clients. So we could say, okay, let's define a successful random generator of clients. So this generator of clients say, okay, let's generate a random list of flights, and let's return a client that will always return this constant list of flights. And then we can do the same for the failures. Let's generate a random exception, and then let's produce a client that will always throw an exception. So now this way we have two generators of client, and then we can use the method frequency on gen, where we say, okay, 9 out of 10, let's generate a successful client, and 1 out of 10, let's generate a failing client. So this way we use frequency to deal with the run, sometimes generate failing clients, sometimes generate successful clients. And I could have said, that there are different constructors for gen. There is one, for example, if we want equal probability between like inputs. But here in this case, I made like successful much more likely to be a bit more realistic. So now if we go back to our test, we could say instead of generating a list of flights and an error manually, we could generate a random client. So we could say client gen, and this will be client 1 and client 2. And then we can remove this list. And in fact, we don't need also instant.now. So now the test is much simpler. Let's rerun it to verify. Yes, it works. So if we review the test right now, it's really clear what is going on. We say, okay, let's generate random clients, then let's search them with random inputs, and at the end, we expect to get a success. So this doesn't define what should happen, what exact flight should happen. We need to have different properties. We may have also example-based tests to capture specific edge cases. But at least this properties really captures the fact that whatever clients we get, we should get a success at the end, which is quite nice. And we can work on this client generator. At the moment, they are fairly simple. I mean, they just say, let's return a constant list of flights, or let's return always the same error. But we could, if we want, spend more time to generate more realistic clients. But it's something we can always, do further on. So it's quite a lot of work to define these generators. But once we have them, we can write very nice property-based tests, which I think it's a good investment. And we could write much more useful properties than this one. So I would really encourage you to give it a try to find other property-based tests from to clients. And as always, you can find some of my answers in the answers module. So great, so I think it's a good moment to take a break. We now have an implementation of from to client that aggregate data and handle errors correctly. In the next video, we'll try to generalize the service so that it can fetch data from an arbitrary number of clients. See you soon.